If we're live there. I did a 3-hour stream yesterday just to finish up some more, but I had some good questions come in for just people talking about asking in the community about whether domain-driven design concepts are mappable to event modeling. It's kind of, you can't win, right? You try to distance yourself from domain-driven design so you don't get pigeonholed. And then you get people saying, well, why aren't you showing this where the mapping is? Like, well, because then people get distracted. They think it's TDD, but it's just a notation. So anyway, yeah, you can't win. So it's kind of neat to have those questions come up. It was a good discussion. All right, everyone, I think we're live here. I'm just going to double check the stream and that my voice and Chris's are coming through. I think I can hear our voice. Yeah, there it is. Okay, YouTube monitor is on, so I can see if anything goes wrong. So anyway, we're happy to be back with Chris Condren, our advisor. Thanks, Chris, for joining. I don't think we got to all the interesting topics and the details last time, so people enjoyed the stream and wanted to see more. So even Martin commented he really enjoyed the stream. He was driving in the snowstorm in Munich and listening to us, so he enjoyed that quite a bit. Hopefully he paid attention to the road more than us, but he's alive and well, so I'm sure he did. And yeah, he said that he enjoyed the stream. So yeah, we didn't really I mean, the topics we cover can't ever be really finished, the discussions, but we certainly want to get into some more details. So I figured, yeah, why not do this with one of our advisors? That's really kind of the I would say you're the repository of all of the really good info on proper ordered event streams out there, indexing and all of that. Having worked for Event Store DB, now called Current, being the CTO there, and now being the CTO of Power Models, especially your large amount of experience in the fintech area or just financial area, anything to do with proper responsible system design around financials. I think it's really critical that people hear from you when they're saying, well, I kind of don't want to do this. Why are we doing event sourcing? You know, so I think for those types of questions, which always come up as the industry pivots to more responsible ways of working in areas, I think it's important for people to hear from others like yourself that have you know, a specific set of skills where I don't think in a lot of cases there is no logical better approach than event sourcing. So
say logical, but it's also on the ground. Right?
yeah,
It's better in, you know, in the theoretical and the construction how you build it, but it's also just so much easier to actually build stuff. Right? You know,
you're preaching to the choir. It's easier for me to
yeah,
build Mickey Mouse stuff when I'm doing the unconference organizational software, but the
yeah.
underpinning logical ways of saying that I have this integrity to my data, I have this reliable audit. You know, I think those same concepts are critical. You know, I could get away with a CRUD app for what I'm doing. I find it easier to build it with event sourcing and plan it with event modeling. But you know, the argument is like, well, it really doesn't matter how you do it. You're doing a crappy little app. I think that argument is entirely invalid when you're talking about running a billion-dollar company with that's based on financial products. So
Well, you know, people ask me all the time because I know Greg Young used to say, "Oh, we'll only use in a little part of your space and do everything else different ways." And I finally decided that I disagree with that. Right? They say if your team knows event sourcing or you know event sourcing, do everything event sourced.
yeah,
Right?
I believe in that.
100%.
Yeah, well,
There's no
I bet the whole company on this 10 years ago, right? Almost 10 years
exactly
ago this September, and it's been the
right.
best decision I made in my life. So
So, but the only barrier is whether or not you've done it before. So, if you, and then the question is, so why is it a crappy app okay to do it for? If you're
yeah,
gonna write it once and never touch it, it doesn't really matter too much, right? But if anything you're gonna be working with for weeks, months, years, going back to anything you're gonna have to debug, maintain, update, make that events first. Because that's where a lot of the benefits of the clarity that event sourcing gives you of what the problem is, what the defects are. Like we've been on a bug hunt with power models as we've been pivoting to a new product focus
hmm
for you delivering for the small market. And we've been in a team of like, I think there's like on this section there's like two or three of us. And in the last 3 weeks, we've found, logged, closed, and confirmed 40 or 50 defects
yep,
on a product that's hundreds of thousands of lines of code, right?
yeah. I
Um,
can I can second that because in nearly 10 years uh, of uh, of doing this at scale, like with teams that are larger, 4, 5, 10, 12, 20 people, and in places that where we don't own everything, but we do have event sourcing. We haven't seen that full cycle that you talked about, finding the defect, categorizing, triaging it, logging it, whatever, and then fixing it and deploying it. Those cycles never go over 4 hours, right? And we have one guy to blame for pushing it to 4 hours. But yeah, it's incredible, when you have that, and people find it hard to kind of believe that that's how quickly you do that. And I've had some interesting topics because I've been painted as a anti testing guy or anti TDD, but I'm really not. I mean, there is testing. It just, what I've realized is that I've been arguing. I can't argue in a different space because there are best practices, and for traditional highly coupled single model CRUD type, which is another way of saying forms over data types of applications, they have best practices how not to hurt yourself there, how to design things in the best way possible. Once you move to event sourcing and not losing information and treating information in additive only form, and on top of that, using multiple projections for different points to have multiple models serve your system, where you have OCP, where you have things not, a lot of the code is not in as much flux as you would with a traditional one. The best practices for the other way do not apply to systems that are built this way. So if you treat information like accountants treat money, and you adopt a multiple model approach inherently by doing so correctly, the best practices shift. You don't have
yeah.
dry. Dry is bad. Dry is a source of excessive coupling, where you're trying to make one abstraction do more than it has to do. And
So I
so,
mean, yeah, so I mean, I've got a couple comments. Like I don't really see how people can say you're anti-testing because you put the test cases in the spec.
yeah,
When you write the timeline, the test cases are right there.
yep,
And I think people also don't think about what. So the real benefit of TDD, I think, is twofold. And the primary one is a side effect. And the secondary one is all the tests, right? Because in the lack of, in the wild west of relational data, right, where you never know, you're never stepping the same stream twice, right? Because your table's always changing, right? You need a whole bunch of tests to give you some sort of security.
yeah,
And what you did today didn't break what you did yesterday, right?
yeah.
That you can
People don't
safely
have,
ignore. Yeah,
yeah, people don't have any trust in the fact that, I mean, some of the old best practices kind of come shining through what you just said, because people are expecting that, how can I change my code with any confidence if I don't have a set of regression tests to catch any mistakes I make?
right. If you're dealing with a situation where your foundation, which is your data, is varying and your code is varying, so now I've got two things that are varying independently. You really need that safety net so you can focus. Because if you can reduce the problem set and keep it inside what you can really think about, then you can be very effective and safe and move forward quickly. But
Yeah.
if you're checking a million things, it's going to take you days just to understand the problem. So the tests give you that great security blanket, and they're absolutely required because of that. But the other thing that TDD does for you, which is really awesome, is TDD makes you factor your code to be testable.
Yes.
It prevents you from building one, these hugely couple things in tiny components.
Yeah.
It forces you to separate components. It forces you to say, "Oh, I'm going to mock this out." What does a mock force you to do? Make an interface, inject something,
Yeah.
reduce your coupling. So if you're overly coupled, you can't even test. So
Exactly.
TDD first forces you to decouple into separate things, and then it gives you a benchmark
Yeah.
to surround.
Yeah. What
There
I'm
are better ways to achieve those two goals,
That's right. Exactly. This
right?
was going to say you're like
Right?
taking the thoughts out of my mind. Yeah. Exactly.
Exactly, right?
Yeah. So you have to
Because
look
that's
at the
what you're doing.
goal of TDD, right? Okay, make the test modular
Right?
and testable. But if you're doing event
Yes,
sourcing and you're doing multiple models, you have that. So now
exactly.
TDD, throwing TDD in there as a way to achieve what you already have is ridiculous, right? From that perspective. So it
You've
does end up
already
being superfluous.
factored it.
Yeah.
Yeah, you've already factored it. You've already clarified it. You already have a simplifying interface, right?
Yeah.
The interface is given set of events, ring this function, produce this set of events.
Yeah.
Actually, given this set of events and this user input or command, produce this set of events.
Yeah. Yeah.
So that's your
Exactly.
test abstraction for everything.
Well, I
So
think
now you're
test-driven development and testable systems got a shot in the arm when guys like Joshua Karyevsky and Goiko Adic, all those folks started to really be proponents of behavior-driven development, where you really started to push the idea that your tests are really a form of specification and driving that further back out into the business realm. So it's not just a developer scope focus of testing or QA or
right.
whoever. That automation has to be intertwined or actually be the spec and the requirements. And I think that's really um, helping fix that bridge between business and tech. But with event
It
sourcing,
stops the
yeah,
developer only like the canonical model in insurance, right? Is oftentimes like 'cause I worked in insurance for probably a decade, and business user would ever understand table structure for a policy because there was so much stuff in it
yeah,
that didn't apply to the other team, right? And so what you find is that the core model that the whole business is running on isn't understood by anyone in the business. It's just in the tech guys. And it's because they're folding all these different things together and then misunderstanding, and then you layer on top of it, and you wind up with this really awful mess,
yeah,
right? And so BDD behavior starts saying, no, no, get into the business user's mind. And what you find is that the language the business user uses and the structures they talk about are much more well researched, much more durable, and lead to cleaner code that factors in the next thing they ask for
yeah,
much, much easier, right? And that's where you get DDD. So then the same concept comes in with BDD, right? And
yeah,
that sort of drove more TDD, right? So it's all about, hey, if we can just write what the business user wants and not some really elegant bit twiddling optimization, we're going to be way better off when we get the next update, when we get the next test, when we ask the users is correct. And with what we're doing with event sourcing, that the event model just lays out. So event sourcing requires you to run through all the steps in order. And event modeling says,
yeah,
okay, run through all the steps in order. Let's do it in a way that everyone on the team can visualize this timeline we're building,
yeah,
right? And that's why that timeline is very often, not always, but very often extreme, right? It's a series of actions that are segmented in time that represent what we're doing.
Yeah, exactly. I think we've gone down a small side quest here for talking about how this is business friendly, but getting back to the mechanics of writing tests, etc. So one of the things that I wanted to do, there was a post that kind of went kind of ballistic a couple of weeks ago, maybe 3 weeks ago, when I said that I don't need all this stuff, like these best practices of writing tests or whatever. I can more or less go back to slapping the keyboard and getting code out. As long as I'm doing event sourcing and event modeling, I know that I have a safety net that's there. And I think it caused so many people that believe in the traditional best practices to get really triggered, because what they've been fighting for 2 decades was
They
basically
live
said,
it and they breathe it, and
yeah,
it's ugly.
yeah,
Like
no,
when it
I
goes
know, I
wrong,
know. It's
the
it's
judicial
funny.
system, it goes so fucking rough.
Yeah,
Excuse
yeah.
me.
But I mean, so I made a second post about that. Okay, let's rephrase it so that people understand, what perspective I'm coming from. And I said, given two choices, if I write a system that's going to either have really well written unit tests, with that kind of gave birth to kind of good abstractions and modularity, but is written in a traditional form with forms over data approach. Key point being where we traditionally apply dry. So you have a user table and you really manage the relationships as best as you can with other tables, but you're forced to, not have a ledger. Just because that's the best way to do things, versus the flip side of saying, look, you can have your ledger, you can have multiple abstractions, multiple models to do this, but I forbid you from writing any automated tests. And so I said, that is not an argument to say that you should write no tests, or you can't write no tests, or I'm not going to allow you to not write any tests. But it's a challenge to say, okay, if you have, a set of people that are good with a traditional approach and do TDD, and you write a non-trivial system, and you have another set of people that are good with event sourcing and event modeling, write the same system, but they're forced to not write a single unit test all the way through. The hypothesis is that you will get the better, more maintainable system with the 4-hour or less turnaround times for defects, with the latter case of doing event sourcing with no unit tests. And I know this inherently from a lot of experiences that I've had over the last 15 years with event sourcing, and of course at the same time traditional apps, because I still have to deal with them, and of course doing TDD and all that since the beginning of agile adoption in the at the beginning of 2000, back in the .com days.
Because
So,
the tests really are their overhead. They're extra code you have to write.
well,
Right?
they are, but I mean, I'm saying that a lot of times they're not just overhead. I think, and I show this on the stream, that you can. They say, oh, testing is against gold plating. I can see where testing is the gold plating, where I'm going down a path of specifying things that don't really make sense, but I think that I'm doing the correct thing. And actually, over specification adds problems. There's a fine line between underspecified and properly specified to overspecified, and looking like you're fully specified, but you're actually doing is you're potentially having things that are at odds. And even the AI, the 5-year-old child that you kind of instruct, will show this by actually, even within a single slice in an event source system, an overspecification in tests forces an infinite loop of whack-a-mole bugs. And that actually, thank goodness, it's contained to one slice. So if you're applying, this TDD kind of, fixed tests, see if they work again, you can very quickly find the whack-a-mole bugs. Whereas I think in traditional systems, the whack-a-mole bugs are things that come back in a much longer cycle. It could be months, And so by the time
Yep.
someone notices, or they might never notice because there's enough of a turnaround in terms of the people working on certain projects that it'll be new to someone that's new to the team, and so you keep going round and round. So anyway, does that make sense?
The fundamental difference that the event source approach, sort of sets the rails for, right, is fixing what was identified as one of the core problems with computer science back in, let's see, March of 1968.
Yeah.
Right? Destrika wrote about who to consider harmful, right? Very famous paper where he said that the problem is the structure of a program runtime is different from the structure of the program as written. And humans don't think that way.
Yeah.
So when as soon as you're going down a program, you got a loop, right? What happens is you actually wind up executing each of those lines of code multiple times.
Yeah.
So you have to track where you are in the code as it loops through. And he was pointing out that when you put go-tos and jumps in, you lose track of where you are.
Right.
Right? And this is the response to that in modern languages was formalized if statements, formalized looping structures, functions. It drove into object-oriented. It drove into functional programming. And all of these are ways to let humans think about code and the processing more easily.
Yeah.
And what event sourcing does is it really says we're going to build Turing machines where any service we have is going to have one stream that comes in, and we're going to operate on that position of the stream, and we're producing output.
Yeah.
Right?
I think Turing machine is lost on this generation, though. They think, oh, that's old fuddy-duddy, when people were just discovering transistors and vacuum tubes, right? Like logic gates.
Yeah, it gives you this. You're always looking at, okay, here's my defined history, here's my decision, here's my output.
Yeah.
1, 2, 3. It's always clear where you are. You're never lost because think about the same thing if your source for input data is a relational database.
Yeah.
You never know the state of that database. Or now you're getting really crazy and you have your QA team build entire mock data sources.
Right.
How do you then start running your tests?
Yeah, that's
Right?
I've been there. That's horrible. Yeah, I think another way to put it. Another way to put it, I think when people, just to rewind back, like, okay, what is the question we're addressing here? So without tests, how does an event source system give you that ability to not worry that you're doing some sort of a tightrope act without a safety net below you? So why am I confident in fixing something in an event source system with an event model, probably, that I don't have a unit test underneath it? Because when I fix a defect, and I don't do it with a safety net of a test, I usually run that one slice. If it was a web app, I can make a bunch of fake events to kind of run through whatever scenarios I want to my satisfaction. And my scope is limited, so I don't mind doing that manually because I'm changing it anyway. I'm fixing a bug. I got to do it manually anyway. It doesn't matter. So why is there no risk with no tests backing that up? It's because I'm not going back to that specific slice or vertical slice of architecture to change that again if something else breaks somewhere else. I think that's the key, is that if I'm fixing a bug in a traditional system and I fix a second bug, there's a % chance that I have to come back to the code that I touched to fix the first bug. With event sourcing in multiple models, you don't have that, or it's incredibly low probability of changing that type. And so when I'm left with just my bug fix in this part of the system, I can happily leave it with no tests and move to this one that I'm fixing and know that I'm not adversely affecting here where I just was fixing the other one. That is impossible in traditional systems without tests. But
Tests
it's
are really isolated. You can do state packages, and there's some ways you can do it, but none of them are really, really good. I mean, it's not impossible, but it's highly unlikely and really painful.
it's very painful because the only way that to
Yeah,
do it really well is to think of, do I have the same scenario in some sort of backup of a QA provided state of the database, um,
and
and
let's
try
also
and cross reference those. But it's still, I think the amount of coupling and the fact that the coupling is only evident in code makes it incredibly inaccessible to work in a way that not just gives the developer the peace of mind that you're not needing to be assured that something you already worked on isn't refactored by accident or changed or has a side effect somewhere else in the system. I think that lack of side effects is really a key point in this. And when we do this kind of exercise to show the concept come through, I think you have to ask hard questions and do the hard challenges. It's like, I believe that unit tests, I can drop them and I can still be good. And that's something that says something about the design. If you can drop something that is so inherently critical to having good design and yet still have fewer defects and nothing come back, well, what does that say about your approach and the best practice? You have to now quantify the best practice. I don't want to see the best practices for traditional systems being pushed on places where there is good design already and responsible information treatment with the audit trail of event sourcing, for example.
so, but let's talk about what that comes about, because one of the things I've found is everyone I know that's built event source systems for a while starts to think about the problem at two levels, right? And you're either talking about, here are all my services or all my, let's call them services or modules or whatever, components, and they're going to need a certain set of events in. They're going to be responsible for some decisions, and they'll produce a set of events out,
Yeah.
right? So at one level, all I'm doing is, am I correct? Do I have all the information I need in my events? Going to the right places? Am I making the right decision? Am I giving enough information to make the decision? Am I producing the right events out to be able to read it? And so in that case, all of the components that are doing the work are black boxes,
Yeah.
right? So, you often use Slice, right? But that Slice is a black box. I've got a series of events that precede it. There's a black box where something happens, series of events that come out.
Yeah.
So you're either looking at this fixed set of mesh of events that drive the system, or you're looking inside one black box. And inside that black box, you have a fixed set of inputs and a fixed set of outputs,
Yeah.
right? And this gives you the focus to go, okay, I'm either inside when I'm fixing this, I've got a mistake in how I go from this set of events, plus this command to this output. Or I'm missing something, or I'm not producing something. So if you're missing something, you sort of set that box down, you go back up, you say, okay, where do I need to get this data from? You wire it in so you get the data, then you go back down to the box and you fix the box. And it's this isolation that's giving you this no side effect. Because I'm only working inside the box. My interface is always defined by the event layer of how everything talks to each other.
Yeah. Yeah, exactly. So like it's this idea that now we actually have workable scope for dealing with units of work, and all that. And I think that you're basically saying that is a facet of good design.
Yeah. And so with event modeling, the timeline is the event interactions, and the slice is the black box or the widget or the state machine,
Yeah.
right? That Turing machine. Is my video frozen?
No, you're just a little fuzzy, but that's okay.
Okay, cool.
I just wanted to point out on Discord that people can fire in their their questions on the live stream channel, because sometimes when people are listening to this, they're like, "Oh, I wish I had a chance to like ask you this question." So yeah, so I'm just gonna tell the community that we're live in case this. I think we're getting close to about 1,000 people in the Discord, which is crazy because we had to switch from Slack, and so it's kind of like a reboot, right? All the people from the community that aren't just you know, old delinquent accounts, because I think we ran a Slack group for quite a long time until they got acquired, and it was just not feasible to do it for public and open source types of things anymore. And everyone's on Discord anyway. I'm just gonna put that in here.
So that's why I think you can get do the no testing thing, right?
Yeah.
Obviously, recommend it because one of the things that happens and you watch out for is like, so the way I always look at it is complexity is the factorial of the interrelated components.
Yeah, you had a good slide on that with a little star shape. I think it's used by a lot of people. You can share that if you want and test out.
Yeah.
Oh, you do look like you're frozen on here. The heck? That is bizarre. Let me reset your camera here. I can hear you, but I can't see you. Let me see. Yeah, there's a bit of a weird slowdown, but that's okay. Let me fix it. It might be OBS here. You see that you're frozen, right? On the stream. Okay. Let me put this away. And I click on this and click on you. Okay, so it's definitely OBS. OBS has this weird caching thing. So if I just go to where is this here? All right. Discord, properties, window. There we go. I think that works.
So here's my.
Oh, good. I thought your audio went out. Okay, good. We're back. Yeah. So go ahead.
And here. So here's
the live thing. Okay, yeah.
Because to my mind, the enemy is always complexity. As soon as we cross out the 7 to 12 things that we can think about, as humans, we're just kind of lost, right?
Yeah.
And so if we have two boxes, they talk to each other. So that's 4 things, right? Each box.
Okay, back up to the other one. Sorry, start again. The stream's good now. Sure. Okay, so the enemy.
The enemy. So one thing is easy. 2 things, if they can each affect each other, right?
Yeah.
Then you got to think about all that. As soon as you go to 3 things, then they can all affect each other, right?
Yeah.
Now we've got 6 things to worry about. And if they're all using the same data tables in a relational database, then they all impact each other.
Yep.
Right? So if they're all using that same schema, it can change. Right?
Yep.
And now we have one more. Classic thing is the business user just wants one more feature.
Yeah, and right? Look how many arrows got added, right?
Right. Yeah. And it all goes crazy, right?
Yeah. This is why we have that. Yeah.
Right. And
this is why.
Where it goes.
Yeah. So like adding a feature a year down the line in the project, it's expensive compared to when it's greenfield, when you only have 1 or 2 boxes to deal with. But when you have 50 boxes to deal with a year in, that one feature doesn't seem so simple anymore, does it? Yeah.
So this is this database schema just about proof Redgate on my computer, just to generate it. This is from an old insurance company.
Yeah.
Right, and to drill in. Like that's a table, and these are all the store procedures around it.
Yeah.
And everything red is inbound, and everything gray is outbound.
Yeah. So if this is insurance, Chris, if this is insurance, if this is an example from the insurance domain, it's no wonder that event modeling is so popular in that domain, because it
This,
gives you a
this
solution
is
to
the
this stuff.
yeah, this is the policy table,
Yeah.
right?
Yeah.
And you can clearly see what should have been broken off as subdomains,
Right.
right? So whatever this is over here, they can't change it without worrying about changes to the policy table,
Yeah.
right?
Yeah.
So
Yeah.
you've got entire divisions and teams that just cannot operate independently, right?
Yeah. Yeah. I think we had the same thing with a transaction table at Pay by Phone for parking
Exactly.
transactions. Yeah.
You find these one like core tables that just couple everything. And the old guys have talked about it for years. You see this crop up again and again and again.
Yeah.
And in this one here, we all recognize, right? This is the same thing with data with microservices, right?
Right.
This is a live map of microservices and their interconnection. And even though everything is separated, and they've still just recreated the complexity, right? So, I made this up as a bit of a joke, right?
Yeah.
Fire more connections, it's incomprehensible, right? The corollary is you can fix this by reducing the connection. Now we
Exactly.
do this all the time. This is three-layered architecture.
Hmm.
The UI, I've got business logic and I've got data.
Yeah.
But we can go one step better. Anybody that does event sourcing recognizes the CQRS pattern,
Yeah. The
right?
projections
Where
that you have to
everything,
go through and then go back
right?
and only add something to the
And,
event store.
right.
Yeah.
And it's all one way. You're like, oh, well, I got to add this and that, and I'm doubling it up. Yeah, you're doubling up the number of boxes compared to 1, 2, 3, but you're so much simplifying everything.
Yeah.
Right? And that's what events are about, is about getting that single one directional time and simplifying everything. So now I can just say, here are my inputs, here's my function, here's my outputs. And we're not dealing with, this craziness with microservices
Yeah.
or with databases. Right?
Yeah. It's the coupling. Yeah.
Right, the couple. So that's the
I'll switch to the other scene. There we go.
yeah. So that's the crux of dividing this into, give me the events and everything that he's talking to, right? And all you care about is the events. And so you have to change one. You're only dealing with those systems that are impacted by that one event.
Yeah.
And if they're not consuming what you're changing, the change is just added if they're not impacted. Right?
Exactly.
So you're reducing the impact and you're reducing the spread tremendously by the fundamental structure. Then with event modeling, you get the timeline. So you're increasing clarity. You're increasing clarity to the business.
Yeah.
Right? And then you're giving very nice isolations with the slices. So once a slice gets complicated enough in terms of how it answers the question, right, then you absolutely need tests. Right?
Well, you
But
might.
until it gets
I might argue
complicated
that you
enough,
break it up. That I mean, you
that's
can
the thing you do.
continue. You can
Right?
continue without tests, right?
Right? As soon as you hit that point of complexity, then you break it up. And if you just measure it on, hey, this is getting too complicated for me to understand. It's one of the things that I always had to hammer into new guys is like, if something starts to get too complicated for you to understand, that's a smell.
Yeah.
Immediately refactor it. How do I break this into smaller things that I can understand?
Yeah, I stopped using the word refactor, because in the thing that you just said, we actually go back and redesign, because we're going to the event model saying this slice is too big. We're actually going to redesign the system so that this one step is actually a series of 4, because then they're in manageable chunks of complexity to fit into someone's head to be a daily task, right? Or to be a slice. And that also comes back, especially if you're paying on fixed cost, that the contractors will refuse to work on pieces of the system, because they said, how the hell do you expect me to do this within a reasonable amount of time? This is the kind of, we're talking about feedback loops. Well, that's the best feedback loop you can have. Someone tells you that you're out of your skull for asking for this. and to be
Yeah.
paid X amount for it, right? And it goes both ways, right? You can have a client
Yeah.
say, "You're out of your skull for me to pay for 12 steps to do the simple thing that I want." Right? So, well, then show me how you would design it so that you don't have
Yeah.
too much complexity. It's a really good navigation of, assumptions about complexity, is that we've just left it to developers to say that what t-shirt size is this, which is a ridiculous way to treat information systems, right? We're treating most of these systems are just information systems, right? And aside any kind of infrastructure work, the actual data transformations, what the end users will see on their screens, it's talking about a responsible way of handling all the cases or the permutations of how your data can flow. And that is not a developer only concern.
I do think it's correct to not call it refactoring. I mean, to my mind, I think about refactoring, but technically, refactoring
I'm
is
just getting
changing.
allergic reactions to the traditional best design
Yeah.
lexicon,
Well,
right?
I mean, what does refactoring technically mean? It means the developer is doing work and changing the code with no change to the user experience,
Right, exactly.
right?
Yeah.
And that's not really what we want to do. We want to like pull out the complexity, and lay it out so the users generally have a better experience as well.
Yeah.
Because everything's like tied up into this
Yeah.
one
So
little
we're kind
thing.
of pulling up that traditional definition of refactoring up a layer. Because now we're saying that, okay, well, we're actually going to be changing, how this works overall, but the user experience is the same across the top. Implementation, you're actually going to have some new interfaces. You can't reuse the same tests. You're going to have different set of tests. So I think if you're kind of hardcore into the traditional way of thinking about refactoring, it's really about, oh, here's my set of tests. I'm adding another test, and now I'm refactoring after adding this capability to make sure that this code that this test suite is addressing
Sure.
is optimal. I don't have a crazy nested for loop. I can do it in this other way, right? That's what refactoring means. But when you bump it up a level to saying, okay, I have this user experience, and now I'm inserting a couple of, 3 or 4 extra processors to dissect the problem to be 4 steps instead of one giant glob that I can't understand. That is a different refactoring, and that's why I would probably call it redesign. I
I think
have a
redesign is
problem
much
with
better. Yeah.
I have a problem with unnecessarily invented terminology in our industry, right? Refactoring, I think, is one of these. Every time in the English dictionary, us old folks get kind of roll our eyes as we have some stupid word make the dictionary entry like irregardless, made an entry just because it's used often enough by enough people. I'm like, what the hell? Okay, so we're just saying, like, even if people are misusing the language and it gets adopted, you're just going to dump it into the dictionary so now they're not wrong. Refactoring is one of those things for me, right? It's an invented term for a specific approach in the industry during the times of popularizing XP. Right? We didn't have refactoring in the 80s. Maybe we did. Maybe it was. Maybe I'm wrong. But I certainly haven't heard about it until I read the Ron Jeffries book in XP, right, or something like that. Probably Kent Beck wrote about it too, or whatever, or Ward Cunningham.
It was always the thing that didn't have a name, right?
Yeah.
Although this does make me think I think I missed a step on the real benefits of TDD. Because one, it makes you so you have to factor your code so it's testable, right? You have to test to not worry about other things. But the other thing that you were talking about was before you make a change, you have to write a test. To write the test, you have to understand the change you're about to make,
Yeah.
right? So, and with, event sourcing and event modeling, that comes from a timeline.
Yeah.
Like, I need to understand the user behavior. What do they want before I go design and implement the slice?
Yeah.
Right? But so do you really understand what you're being asked? Do you understand the nitty gritty of how it's supposed to work before you start implementing
Yeah.
it? And, IBM proved that the earlier you push that stuff, the cheaper it is.
Yeah.
It's an order that's 10 times more expensive the farther down the process it gets to find
Yeah.
and fix a defect. So I can find problems an initial spec, it's like 3 or 4 orders of magnitude cheaper
Yeah,
than
exactly.
finding shipped defects.
Yeah.
Um, and that's where that formal model, right? The measured drawing approach with the timeline forces you to find all those questions. And then once you find those slices that are too big, then redesign them so they're not. Because I will bet you that if you have a slice that's big, you're requiring special user knowledge to know how it works or what to do.
Yeah.
You know,
Well, we see
the
that in
complexity
insurance with
isn't
those
just
complex screens for policy, right? The accordion
yeah,
menus that end up in that UI, and somehow, yeah, that policy is a great example of this. You know, from your previous when you shared
yeah,
those crazy connections, the amount of
yeah,
connections that you have, right? That a lot of times those types of things are sitting in one step, and it's just, you know, how is that communicated? How's someone going to know what to do? It's
yeah.
crazy.
Because I mean, you think about it, like a policy to the sales rep. It's a contract. It's a commission. It's got a related reseller.
Yeah,
You know, for someone who's doing like right now, catastrophe analysis,
yeah,
CAT analysis, what they really care about is where's that policy located?
yeah,
Like what group is it in? Is it in LA? Is it in Florida? Right?
yeah.
And then someone who's just doing claims, well, we've got exposures and we got limits, completely different views and data sets
That's
that
right.
are really only joined at the root of it by an ID,
Yeah,
right?
I think that
But you,
whole industry, because of what you just said, the different perspectives to the same entity
sorry,
of a policy
yeah,
is exposing the shortcomings of the traditional approach to software, and that
yeah,
no matter how good you are at doing the best practices for traditional approaches, you're going to have a nightmare time in insurance,
all right,
simply because of those separate concerns that are always forced to be to try to be serviced by one abstraction. But you can
yeah,
try to do domain driven design and try to have a different view into the same thing, but I think the actual gist of what's going on is best served by event sourcing, because I'm
yeah,
forced to make a projection for the purpose of the task I'm doing, for example, for
yeah,
sales or for whatever. And then I look at the stream of events and I can say, well, I don't care about this, you know, from paying out or getting payment on premiums or something. Do
yeah,
I care about the address or whatever? I'm just accounting. I'm just going to send them a bill. I don't really care what their coverage is. I just have to say whether they're currently in the policy's in effect or not. And if it is, well, they have to pay their premiums. I'm going to go send a collection agency after them, or I'm going to give them a warning letter that they're not going to be covered unless they pay for the missed payments or whatever. So they are forced not to do that. So what's happening with event sourcing is that you're skipping the butting your head against the wall trying to unlock a locked door, and you're walking around the brick wall. You're attaining the goals of what the best practices in traditional development are by saying we're
yeah.
not going to do this in a traditional way. Ironically, it is the traditional way of
It's
information
very
systems before
traditional.
computers, right? So that's the irony, is that we've gone down a specific set of patterns because computers. Wow. So we've screwed up
Like
how organized information
we
systems
are
were.
really, really good at complicated things, right?
Yeah.
It's
But you also got a bunch of
the
nerds that wanted to play and not be bored. So do I take another ticket, or do I get to work on a new
I
feature? And maybe I will gold plate it because it's way more fun than doing the day to day grind. And we
I
had
don't
this, yeah,
I'm not nearly so negative about it. I just think it's good smart people solving the problems in front of them with the tools they have to hand, right? And as we're coming around, we have a new toolkit that makes that much easier. But to use the new toolkit, you've really got to relearn and change what you're doing, right?
Yeah,
You
absolutely.
know,
There's a different set of best practices if you're coordinating multiple models versus trying to make a single model fit, a dozen different use cases.
one of the benefits that event sourcing brings because of the linear nature is you get a logical clock, right? You get a Lamport clock.
Ah,
You're
yeah,
not
let's get
dealing
into
with all
that. Sorry, Chris, I'm going to
right?
interrupt you because I think
Okay,
this is a good time to take a 5 minute break to get some water, go
right,
to the bathroom, whatever. Because I like talking
sure.
to you, but we always talk for a long time because we have a lot to cover. So this is good. But I'm my cup is empty, and so I
Same
think
here, same here. I
I
can
think
definitely
we can get some
do
more
some more
caffeine,
coffee.
and we'll be back in 5 minutes. I hope that I think it's yeah, Discord might oh, hold on a second. Yeah, Discord might drop us. But
It'll be
if it
fine.
does drop us, I'll reconnect us. But I'm gonna make a beeline for it, get back in front of the camera, wave my arms so that Discord doesn't drop us because they try to save
Right,
bandwidth
yeah, makes sense.
by dropping. I think that happened to us last
Well,
time.
and that's also in my voice because I got the vocal damage from the cancer. So many times I get edited out as background noise. It's
What?
so
That's
annoying.
horrible.
Yeah,
Okay, well I hope that AI gets better. This is people that are poo-pooing AI and like for certain things like what you just said, especially around medical things, it can't come any sooner. So anyway, 5 minutes. I'm gonna try to rush back earlier so we don't get disconnected. Okay. Oh, there. Your voice is back.
so um,
So we want to get into the
so
next topic here.
well, it's really all part of the same thing, in general. But the
Yeah.
next topic is Lamport clocks, right? And Mr. Lamport, he's a great computer scientist still active today. You know, he is dealing with a problem with messaging, right? And the problem with wall clocks. Because how do you synchronize systems using wall clocks?
Yeah.
Because you can't do it. Because even with like GPS, they have to adjust the times in the satellites for relativity, right? So you're never going to be able to
Isn't that
synchronize
crazy that
databases.
people
Yeah,
don't realize that you actually have a proof of theory of relativity?
there, right there in your phone with your
Yeah.
map application, right? And so what he said was, okay, so rather than trying to use wall clocks, why don't we just count? If everything comes over a wire, and we have all these messages, we just count the messages. And we give each message we've seen a number, and we put that on the message. And now I can say, okay, on this stream of messages, I've gotten the message 6, right? Or 7, right? Million. And then we have multiple streams of messages because he's dealing with messaging. I can then group those together, and I can say, okay, if I'm synchronizing these 4 message streams, then any member in the cluster can say what they've seen on all 4. And that comes together to form a compound number,
Yeah.
right? Now, the difference with event sourcing is we're not just firing the message around willy nilly, like Kafka or other systems.
Yeah.
We actually have an ordered and persistent log. So any message that we've seen that's been persistent can always be recovered to a certain position,
Right.
right? And so this also goes back to the your aggregates and your streams and your dynamic context boundary, right?
Yeah.
Because what we're saying is that, and for any stream that I can see, I can always put a count on it and get a logical clock to know where I am. And this
So
is
it's like
the
a place.
crux.
It's less about time. I'm here in the information stream.
It's position, right?
Yeah.
So we use position in the stream to replace time as a clock in the wall, and that becomes our logical clocks. And now once I have this clock, I say, well, this system is ahead of that system because it's seen 2 more events,
Yeah.
right? And how do I synchronize everyone? Or at what time, position did I see this other system? So in our policy example, when I create a risk assessment of policy, I can say, well, I looked at the policy from the central system at a point in time X, and it was in force. So at this time, when it was in force, this is all true. At a later time, when, say, it wasn't paid, it's not in force, now this stuff isn't true. But I can align those and I can say, okay, here's what I knew and here's what I saw when I saw it. And so I can just link these all together and always be in a known position, which you can't really do with multiple databases or multiple systems without some sort of logical clock. Now, you can apply a logical clock to a relational data table. Really, all you're doing is event sourcing all the updates.
Yeah, which is kind of goes back to you're exposing the transaction log of the database.
Exactly. Right, and that's what often change data capture does. The problem is that because it's not intentional, you lose so much information. And once you've lost all that information about why the change was made, who made it, all this stuff, you can never regain it. And that gives you tremendous amounts of accidental complexity as you're trying to rebuild information you already knew and you threw away. That's a different conversation. So with logical clocks, I can now have the clock on my stream. I can have a clock on multiple streams, join them together, and I can even represent that joined stream clock as a single position. And that's where you get hierarchies. Like, something about like invoices. I have invoice 592, and it's in stream position 501.
Yeah, I think a real world example of that clock would be invoicing numbers, because some companies may just have a generic number where they just keep adding, a 1 to get the next number. But others may say that I will put in, the first, like an acronym of 2 or 3 letters of the client that I'm recurringly having interactions with. Of that's like AG for Adaptec Group -001, because that's the first invoice to that client. And so
we can separate it out. Yeah.
I mean, so when you're talking about these hierarchies of these indices, this is kind of something that everyday people will see and understand.
And that's from Event Store. That's what we call categories, right? Right. And so invoicing would be the category. And so you have an index stream of the category, which is all events in order on all invoices. Right?
Yeah.
And now I can remember one position on the category stream, and I know exactly what my entire invoicing system was.
Yeah.
Which is really great for failovers and backups and other things. So I can lose my whole database. I can go from the stream to the category to the schema to the database and still have one number that represents the entire position, which I can now compare against another backup copy if I want to distributed recovery. Right? And
you gotta say, like, why are we concerned about this? And this is about making systems available and yet retain integrity, so that even though we have a lot of problems where people try to make things available and scaled, but the information's not reliable because they haven't taken care of allowing you to really understand where you stand in the greater order of things, and whether your invoice came in earlier or later than someone else. Well, it's really critical in places like auctions and then legally on the logical scale. Well, think about it.
Did the late charge of the payment come in first?
Yeah, exactly. And to kind of, I always like to throw things back to where we were doing things on pen and paper before computers, and this might be check is in the mail. Who received what? Why do you have registered mail? Why do you require someone to sign that they got something? That's your ACK, right, from your message receiving and things like that. So I don't know if that's a good way for people to sort of understand the Lamport clocks, and starting to look at subcategories of indexes. I think we're leaking into
Yeah.
the next topic here, which is indexing in general, and kind of how we loop back to what we talked about last week with dynamic bounded.
So once you realize you've got an order in the master law,
Yeah.
and an order in a stream, and an order in any category, you then realize you can have an order on like exception events, or an order on creation events, or an order on anything else you want, and you get that same clock position, which can be multi-part, which is here's the fifth, here's the fifth exception event I've seen. It's at position X in this stream, in position Y in the log,
Yeah.
right? And that's all down in the infrastructure. You don't have to worry about it as you work with it. It makes it easy to create any event storage system you want. Any persistent mechanism should make building these kinds of streams, consuming them, and saving positions on them easy. Because those positions are what you put in your caches, right? So if I want to have my caches always be correct, because people talk about eventual consistency and it always pisses me off. Like in an event source system, there is no eventual consistency.
All
Because
systems are eventually consistent.
no, the technical definition is the system will iterate around until they all become the same value.
Yeah.
But that means that some of them can be wrong in the middle.
Yep.
With event sourcing, you're never wrong, you're only stale.
Right.
So I call it ordered consistency. Because
Yeah.
it's entirely different if you're telling a user, well, it might be wrong, but if you give it some time, it'll get it right. Versus, well, you might be looking at the one from last morning,
Yeah.
but you're never going to be wrong.
Yeah.
It might not be like right
Up
today,
to date. Yeah.
but you're never wrong. The information you're seeing is always valid and generally at a very reasonable point in time close to where you are.
Yeah, exactly. I like that. Stale but never
Yeah.
wrong instead of sometimes
Right.
wrong.
Yeah, stale, not wrong. Totally different than wrong.
Yeah.
And
I think people
so we're always
don't
correct.
understand that, and they blame the staleness of the source of the error, and then that is just a system
Right.
design flaw by people not saying what are the requirements and what are the SLAs. It's one of the reasons that on that event modeling allows you to draw a red arrow saying what the SLA is between a couple, however many slices you want to talk about for that concern.
Times I've seen people say, well, we need this system in real time. Like, what? Well, because when I send that email to my boss,
Yeah.
I'll copy the report in it, it's got to be real time. I'm like, okay.
Yeah.
Well, it's not
By
real
the time he reads it, how much time has passed?
It's the updated version of we need to print these reports at 9 a.m. and they have to be real time at 9 a.m. every day.
Yeah, exactly. Because something really happened. Something really important happened at 8:59, and we're going to read them at 9:01 to make a decision by 9:02. Yeah, it's ridiculous.
So all the time I'm talking about this was I said, because I was dealing with like trading rooms. I'm like, okay, so the senior committee makes a decision that this stock is trades in blood diamonds, or for some reason it's outside the company's ability to hold it.
Yeah.
That decision is going to be made in a room upstairs at say 9:15 in the morning.
Yeah.
Is it okay for a trader at 9:30 to buy that stock?
Yeah.
Well, yes, because they're still in the meeting.
Yeah.
They haven't published the meeting notes. No one's entered in the system.
Yeah.
Right? So the decision's been made, but it hasn't yet been shared.
Yeah.
Right? So the limit is actually after the decision's made and then it's communicated and then put in the systems, then everyone needs to plan to unwind those stocks.
Yep.
And then if they buy it, well, now they're trading, right?
Well, what if you had an automatic, already had an order in place for the day, and you're the broker that went out for lunch and you're not back for another 40 minutes, and in the time that you were at lunch, your order got filled? Do you get blamed for it?
Right.
I don't know.
So is that a right? So with event source systems, we know that when that order was placed, the state of the core system did not have that exclusion in it because we have the order that everything happened.
Yeah.
So it is now provable that when that order was put in, the exclusion was not in place, even if it resolves after the fact. And so many times people don't think about this happening,
Hmm.
but this interleaved ordering in time causes huge problems.
Yeah. But
And
it's the
people try,
reality of how
it's real.
systems work. That's why you have
Happens all the time. Yeah,
well, think about I mean, pretty soon we're going to be getting into 24/7 stock markets, but right now, there's the end of day procedures after the trading floor has closed. The what is it called? Reconciliation time, or what is it?
conciliation, right?
Yeah,
The entire shadow industry
yeah,
that props up relational databases.
yeah,
Like, they've got entire teams of hundreds and hundreds of people that do nothing but fix the bad data
yeah,
in all the relational databases on a timeline so the next day everything's correct,
yeah,
right? And and they spend tons of money when they do find material errors that they can't fix internally. The corrections have to go out and get processed. They all cost money. And so on top of the cost of the people, it's just huge. Um, Nobody talks about it. You know,
it's
everything's
called
fine.
settlement, right? It's like that, isn't that what it is
Yeah,
at the end of the day? Yeah,
yeah. So reconciliation is a prereq to settlement,
yeah,
right? And sometimes it's called part of the settlement process.
yeah,
But that's where they all go through and go, okay, well, what really happened? And as soon as you have an event source trading system, not all of it, but all the parts you can control just get resolved,
yeah.
right? Because you always know where you were in time. And that's why once you get that, once you really start thinking, okay, I can trust, I can take any set of streams, make a position on it, use that for a cache, and now I can trust it and use it, know where I'm at. And I can always go back and say, okay, so now I'm just asking the source system one question. Am I stale?
Yeah.
And if the answer is no, I move on. I
It's
don't
a
re-query everything. I just say, am I stale? Oh, okay, well then give me the stuff I missed. And it's super efficient to keep these flat cached tables or graphs, documents completely in sync.
it
So you can do nice,
addresses
fast tasks.
it addresses another key problem that traditional systems don't address really well because of the mutability of state or how you store state with mutable artifacts. And this is the cache invalidation problem, right? It's cited as one of
Yep.
the hardest problems in computer science or computer or just systems automation. And cache invalidation, how to do it responsibly and all of that. If you're doing event sourcing, relatively speaking, it's not an issue, which is a tough claim, right?
So using an incrementing clock, right? And so using incrementing clock at the data source and using a Lamport clock, you can fix missing message, off by one, and cache invalidation all in one shot,
Yeah,
right? Because
it's
what you did is
crazy. I
you,
mean, we take it for granted,
yeah,
and that's why every time we do a workshop, it's like, oh, it's the same old. Like, I don't know if it's gonna be worth people. And then in the workshop, I see like, holy smokes, the entire industry is blind to like having another door open right beside the one they're banging their heads against,
yeah.
and they just don't take it because they see everyone else there, right? And it's
You
it's
can
it's
just
tough to stray
the
from
concept
from yeah,
the concept that you can trust your cache, you can efficiently update it,
yeah,
and you always know where you're at.
yeah,
It's just people are just like, what do you mean? So you can also say, okay, well, the user saw, so you're gonna have a cache that drives your UI, and this can be a version, and then you put that version on the command that comes in. So you can say, okay, this command was sent down to the system seeing this data. Has anything changed since that command was issued?
Yeah.
Right? And so now you can, and that sounds like, okay, a little complicated, but now it means you can safely run completely in parallel
Yeah.
with with an optimistic concurrency lock.
Yeah.
So not pessimistic. Now I'm not locking everything.
Yeah.
I'm only saying I'm going to run as if everything's going to work, and only in those places where I have high contention or I have a problem or something went wrong, do I ever go back and look at doing other kinds of locks.
Yeah.
Because there are some places where everybody's being up on the same stream.
Yeah.
And
And I
maybe
think
that one you have to pessimistically lock.
the requirement for pessimistic locking in traditional system is kind of a good way of saying why it favors a single model
Yeah.
abstraction, because you don't want to have, like, if you have a multiple model thing and you have to do pessimistic locking everywhere, that's going to be a really crappy database to run.
So what is it? So I think this gets to the heart of why the relational database is so entrenched.
Yeah.
Because before you had the relational database, well, in the relational database, just one. So before you had the database, you were writing the files into input streams and output streams. And you had no way to coordinate all of these updates. So you were constantly dealing with problems. So the first place they solved it was the mainframe. So all updates get linearized by the mainframe.
Yeah.
But then we were out of that, and now they say, okay, all my changes for this app get linearized by the database.
Right.
So now I can linearize through the database, and internally it's doing a series of updates in order.
Yep. It's doing what we want to do.
Changes. Yeah. But then they didn't see why they would want it in the app, so they throw it away and they just give you the results.
Yeah.
Right? And that works really, really well until you have more than the app on your desktop.
Yeah.
As soon as I have a bunch of people in my company who are all changing things, well, now they're all locked to the database. This is the rise of Oracle. Oracle's really, really good at scaling and ordering large distributed systems, right?
Yeah.
And so it lets you get bigger and bigger and bigger with the pool.
For a lot of money.
For a lot of money, right? But then we get to the cloud. And once you really truly distribute it, right, none of this is going to work.
Yeah.
It's all just going to fall apart. And that's when we have to go back
It's a losing game. It's a hockey stick curve in costs.
Right. Well, and it's just just giant databases aren't, the cloud vendors don't support them. They cost you a ton of money. It just doesn't work right.
Yeah.
You need to have distributed systems, and now we need some way to keep them all in sync. And we find that Paxos, Lampert clocks, logical clocks, all these things. That's
consensus algorithms like Raft, Casper. You see that in blockchain stuff too, right? I mean, it's a slower version of all these things, but you have this. Yeah, you have the same things at play.
So it's inherently distributable and scalable to be able to use event sourcing, because you're getting your logical clock from your data source, and there's known and easy patterns to combine those clocks with multiple data sources. So it's much safer to have distributed silos or to read into different silos, because all of this distributed processing is solved. Sorry, I know I'm going off on the deep end.
No. This is actually highly relevant, because I don't think people realize, just because they spun up a Rails new app, they don't understand, or something else where you have a framework and it's sitting on top of Postgres or whatever, and then they migrate it to something enterprisey. It's really important for people to know what they're dragging in. Just because you can't see it doesn't mean it doesn't exist. And this is one of these things that, traditional systems are quote unquote easier. It's like, no, they're not. They're incredibly complex and hard. What you're looking at is a set of incredibly mature tools on top of all this. Make it easy to deal with something incredibly complex. And the worst part is that complexity is not necessary 99% of the time. And
because what you see is that we move the complexity into the database. right? And then you see all these papers from these great scientists on database optimization and scaling and locking, and it's all just taking it out of the developer's hands.
Yeah.
And what we really need now is, you know, I think we're 10 to 15 years in to the to what I call the stream databases, right?
Well, the alternate
Where we're actually,
databases. I think 10,
yeah,
15 years ago, we started to see things like the key value stores, the Mongos, and all that. It's like, oh,
right,
look, I don't have to have something stupid expensive to, or clumsy to coordinate like a relational
yeah,
database to just do this, this web page or this app. I think a lot of this happened when smartphones started to come
consider,
up, right?
yeah, yeah, I consider event stores. So those are even older. Those are 20, 25 years now.
Yeah, but I think they
So I
came
consider,
into real adoption a little bit later. There's a ramp up time.
yeah,
They
yeah,
did exist a long
yeah,
time ago, I agree, but I don't think
right,
mainstream. They went
yeah,
mainstream around 2010,
yeah,
I think.
yeah. Because I think it was Mongo with the website caching and the basket, like the
Yeah,
state basket
yeah,
and Mongo. They go together like peanut and jelly,
yeah, yeah.
and they just exploded, right? Um, so I consider Event Store to be a type of database, a stream database.
Hmm.
And one of the things that I've demonstrated is that that type of database can be the root for any other schema or source
Yeah,
because it doesn't lose any information
yeah,
and it has the most complete information schema. And all the others are derivable
yes,
from a properly written third. So a third normal form event stream has all the information, if you include categories
yep,
and higher level ordering, to recreate any other database. But
exactly.
none of those databases can recreate the original data source from the stream.
Yeah, they're not built for that.
So
It's not to fault the
right,
authors of these things. They're playing into what the industry thinks it needs at
yeah,
certain periods of time. And I think this is kind of like local maximas, right? People try to keep finding if you look at a 3D map of your solutions that you have in the solution space for these technical things, we're all kind of at the very top circling this one approach. And there's a lot of money to be made in saying that you
yeah,
can be this much better than the other if you just use Oracle instead of SQL Server, and the salespepeople force you here and here, and then
yeah.
the company you're
With
with ends up
Oracle,
going with this, right?
I can train Oracle MQ into the transaction to write to the table. So now my messaging infrastructure, my data infrastructure
Yeah,
get locked together, and I can trust everything.
but
And
because
it
I
only
said
costs
local
you,
maxima, right? There
yeah,
is, why don't I treat information a completely different way and notice that the local maxima there is like orders of
truly,
magnitude better,
right,
right?
truly distributed information because you're still saying, I've got a single point I'm going through. My Oracle cluster, everything goes through the Oracle cluster,
Yeah,
right? With event sourcing, you're naturally starting with a distributed friendly, multiple database,
yeah,
multiple source that has all the tools you need
yeah.
to truly be distributed and safe. And it's so much easier.
Yeah, I think I mean there's the industry is always changing, tech is getting better and all that, and I think so we have the thrashing of the possibilities is destabilizing that local maxima of RDBMS for everything, where you have to look at it, and one of them is AI. We have to touch on AI because if you
Yep.
inherently have, hey, look, event sourcing doesn't lose any information. You don't have to go through and extract from backups or instrument some crazy history tables and some not reliable publishing.
It's lossless.
Yes.
I know there's people who are using, event sourcing to save their states for the data set they rolled into it. So because you have this lossless data store, you can reset to different points of times your training data and your algorithms, and you can actually reproduce particular forms, so you have this approach you can do stepwise. So without it, you just can't. There's no way to be able to.
Yeah.
Hey, we're rolling up on 2 o'clock.
Yeah. Did you
I
want
do have
to
to get
talk
going.
about a little bit, take one more break and talk about power models and the Excel, the ledger of ledgers or the meta ledger? You want to do that?
Dude, but I am out of time.
Oh, are you out
Can
of
we do
time? Okay.
that next week?
Yeah, let's do it next week.
Yeah, so
Absolutely.
So
See, we
in
always run
power
out of time to
models,
discuss everything. We
yeah,
always run out of time.
yeah. So power models is an event-sourced application that services its UI through spreadsheets, but to do accounting. But it then uses the accounting ledger to generate all the reports and timelines. So
Yeah.
it's an event-sourced accounting approach on top of an event-sourced system.
Yeah. Yeah. That's going to be good
Yeah,
to unwind that next time, because I mean, there's
yeah,
lots of interesting side topics in event sourcing, and one of them is, I've tried to extend that into the meta layer as well, to say, well, if you're going to have nodes in your clusters that are inherently event sourced, how do you do blue green deploys with these things? Can you
yeah,
actually put, as we discussed, vector clocks? Can I
yeah.
capture the meta event of upgrading this projection? When was this projection in effect from?
100%. Yeah.
Exactly, right? So,
It's
so
just another stream.
just
It's
another
just
stream,
another
right?
position. Yeah,
Exactly. But now what that gives you is that I'm no longer guessing and looking at timestamps
yeah,
for when something was in effect, even if it's in a highly automated way where we have these blue green deploys switching out nodes to do new business logic. I actually have a non like a trusted marker on the ledger of when the users were using a new
yeah.
view of that information, right? So there's a lot of interesting topics there about how real time do you want that information. Is it something that you have to make another projection to get that? Like, we have a bug in the system, but I have to ask myself, was the user looking at um, a report that just got updated? Were they looking at the old report or the new report? How
Right,
how
exactly.
how hard is that question to answer? One of them is, to have some hashes or embedded versions or semantic versions of, like, you issue a
Yeah,
command and the command took some data in. Do you have a marker for which version of the read model was used to on the screen when that button was pressed to issue that command?
yeah.
Things like that. That's really cool, but you don't have to do it explicitly like that. I think we have things that can be baked in at a lower level
Oh yeah,
to have
yeah.
that
You just
graph available,
so
right?
when you click the button and we assemble the command from the view model, we just grab the view model version.
Yeah.
And that'll include in it the streams that comprise the view model.
Well, yeah, there's
So the viewers
lots
are
of
able,
ways to solve that
yeah,
problem. But
and
it's
you just erase it
interesting.
and set it down. Yeah,
But regardless, what you attain in any of those methods, if you're doing event sourcing, you have a definitive answer. When someone in
yeah,
support looks like this person had this error because they're still looking at the old version, or this is a bug with the new version, you're seeing the first one, and it's going to come up once a week, right? So
yeah.
those are the awesome answers you can get with this. Where I think with the traditional systems, you don't have that. Like, you just it's very. I
So
mean,
like,
it's hard to attain that. Much harder to attain that.
nobody does it for real. So one of the things that I'm excited about talking about Power Models. So we're at powermodels.io, and next week I'll walk you through what we're running after the beta. So we're just going into the beta program.
Oh, awesome.
We've
Yeah,
got
we
some
would like to
really
see that.
exciting stuff, and I can give everybody a preview
But I want to
of
geek
the
out on the
types of
things
reports.
underneath
Oh
that
yeah,
are making it run, right?
oh yeah,
I
well,
appreciate the value of what
yeah.
Power Models is doing, but the geek in me wants to see how you made it work.
And there's this recursive fractal nature to the architecture,
Yeah,
which James Nugent has said it's always a sign of something good. So I'm really
yeah,
really happy to see that in what we're building.
yeah. That
Because
would
we
be good.
just take the full journal of your accounting system
Well,
and then turn it into the actual reports.
there's no shortage. I'm surprised. Like, okay, I'm doing the podcast with Martin on Sundays. We record on Sundays. We release sometimes during the
Right.
week when I have time to go through it. And then we've now had two discussions, and there's just no shortage of topics to cover.
Oh yeah.
I thought, like, back in 2010, I think we got it. No more to talk about. It just, like, continues. Like, once you see,
If
a
anybody,
better way of working, it just precipitates out into all these other problems and how they're solved by this new approach, and just discover new ways of where you applied this. There's these beautiful positive side effects and core benefits to so many other things. So Anyway, always good to connect. And so, yeah, let's continue doing this as a regular thing because I think a lot of people are, are asking about the core things you have so much insight about. Eventual consistency always comes up. And I think, if I was to say who in the
I had the
industry,
pleasure and the time to focus to really look deeply at these questions and answers.
yeah,
When I was working with that event store, to say, okay, what's really going on here? How can
exactly.
we make this better? How can we solve this for people? That was my job for
Yeah,
years.
yeah,
So I've had this luxury of really getting these deep insights and talking about them.
yeah.
So
I think it's
I
really
love
good for the
sharing it.
industry. Yeah.
Yeah.
To have this because I mean if someone was if someone had scaling issues and they were to put together the A team to go in and do that, it's like, okay, let's head in with Chris and Matt Bishop and some of the other advisors that we have and go and solve this in the proper way from the get-go. But not only that, but have an honest estimate of the effort and then be able to actually put in a roadmap to attain those scaling issues from that perspective. And then there's the accountability aspect, like how do we make these reliable? And there's the other things like how do you maintain these systems? And those are all coming in from all these folks that have come in and focused on this. And your focus being at the okay, how does a trading system do this? When do we repeat information in an event for ledger like stuff so where we absolutely need to not have the round trip for eventual consistency? That's the person I go to you for that, right? That's awesome. So thanks for joining the live stream, and I'm looking forward to next week. So good luck with the beta.
And everybody has any questions, drop them in the channel.
Oh yeah. Well, we actually had a comment. I think we had Yo8 actually. So
That's York.
yeah, I know, and he's in Canada now, right? In Montreal. He's moved from France, right? So he had funny how optimistic concurrency checks work so well with transaction logs. Very easy to implement in this context. That's it. That's his comment. But yeah, he's an awesome guy. Also a Linux freak like me, so I always like talking to him. He's always busy. He's always coding, and so it's hard to get some time with him. But I think I had one or two live streams with him a couple of years ago. So I think I might have to republish those because he has a really good insight on stuff too. And he also worked at Event Store, right, with you at some point. Yeah. So that's pretty awesome. Good to see people like that jumping in on the stream. So don't miss out next time. Same bat time, same bat place on Thursday, 9 a.m. my time, noon Chris's time on the East Coast. So join us next week for another in-depth discussion. What's that?
6 p.m. in Europe, and 5 or 6 p.m. in Europe. So.
Yeah, 5 or 6 p.m. in Europe. So that's actually pretty good time slot. Thursdays are good. People are wanting to get some information injection into their way of working. They're not as tired as Friday, so I like Thursdays to be information days, and this is probably the best use of it. So thanks for joining, and have a great rest of your week. Looking forward to the beta. So see you, Chris.